So for this, we're going to study the measurement of locations, mean, mode, median, quartile, percentile for group data. Alright, for group data. So first look at your mean. So your mean X bar in group data, you need to find out your frequency and your X. Your X is your midpoint of your class. When you have group data, means your data will be organized in interval 1 to 4, 1 to 5, and then 6 to 10, then 11 to 15. So it's already in a class. So to get X, it will represent your midpoint. So how to get your midpoint? Plus lower limit plus upper limit divided by 2. So the midpoint here will be 3 for this class. And then for show out and so on and so forth. Mean. Alright, so sum of fx over sum of x. So if mode, so measurement of location, everything need to identify the location first. To find mode, so you need to find out what is your mode class. Which one? If I given you frequency, you have to identify which class first, which interval first. Pastikan class dulu, position mana dulu. So from that class, let's say this is your mode class. This is having highest frequency, let's say 10, others just 3 and 4. Okay, so our mode class is 6 to 10. So identify out the class first, position there. Then from this position, only we find out what is your L. L means lower boundary. Lower boundary, so 6 and before that 5. So lower boundary will be 5.5. Alright, boundary. So between 6 and 5. To get a boundary here, 5.5 lah. Alright, then what is D1 and D2? D1 is the difference frequency before previous the class, and D2 difference the frequency after the class. So this is D1 before the class, the difference of the frequency, and this is D2. So the difference here, D1 is 7. The difference after the model class is 6. Alright, so D1 and D2. D1 is the difference frequency before the class. D2 after the class, after the model class. And then C is what? C is class width, or we call it class size. How you calculate? Don't use your finger. Use upper boundary minus lower boundary, because your group data not only for discrete data, you might have an interval for continuous data, as I showed you before this. Still remember now? It can be 1 until 6, then 6 until 11, then 11 until 16. So what's your boundary here? 11. What's your lower boundary here? 6. Previously your secondary school all is discrete, so you have a number that skip. So now when you're doing with continuous data, so your interval maybe it is continuous. The lower boundary will be same with the upper boundary. The lower limit in the class and the upper limit of the class will be same as lower limit for the next class. It might be same in interval, okay? So use your boundary to find your size of the class. Don't calculate 1, 2, 3, 4, 5. Don't calculate by your fingers. Alright? Then, okay, so next measurement of the location, median. Same also. Firstly, find out what's your median class. So this L is your lower boundary of the class. N over 2 is your position. This is cumulative frequency before the median class. This F, small f is your frequency of the class. Lastly, C is size. So upper boundary minus lower boundary. So actually for median, for quartile, for percentiles, the formula look alike. Look alike, just the position difference. Median we put N over 2. For quartile we put depends. If you want first quartile, here position we put 1/4n. If you want third quartile, the position here we put 3/4n. Alright, so if percentile depends. If I want 11 percentile, the position I will put 11/100n. So actually the formula they are alike. It will be lower boundary plus position minus the cumulative frequency big F before the class over the frequency itself, then time with size class of the size class width. Alright, so they are same, just maybe the interval difference only, the location. So quartile you cari lah kat mana class dia. Alright, so class boundary ambil, you will take class limit, add on and divide by 2. So like what I said just now, this one. How to find this boundary? Add on, divide by 2. So 5.5. Add on, divide by 2, 6. Alright.